Hello children, today let us discuss about bases, right? So today we are going to discuss regarding bases. So what is a base and types of bases, right? Preparation of bases, properties of bases, all we see in this class. So try to cover mostly our complete topic of bases, right? So what is a base? So base is nothing but substance which increases the OH minus ion concentration in water. Normally, we can divide water into water. We can divide, it can be divisible into H plus ion as well as OH minus ion. So whenever you add base, so let us take some base like sodium hydroxide. So whenever you add the sodium hydroxide in water, this will dissociate into Na plus ion as well as OH minus ion. See, already it is having OH minus ion, still few more OH ions are coming to add this. By this what happening? So your hydroxide ion, OH minus ion concentration is increasing. Similarly, if we add NH3 to water, then this will become into NH4OH and this will dissociate into NH4 plus and OH minus ion. So when it is added to water, it is converting into NH4OH and dissociating into this. So here hydroxide ions concentration is increasing. So that substance we call as base. So for the base definition, bases are the substances which increases the concentration of the hydroxide ion in water. So whatever the substance, so there are many bases: lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide, zinc hydroxide, right? So these are the some of the bases, right? So here there is one more word we get, that is alkali. That is alkali. So what is alkali? Alkali means that is also base. But the specialty of alkali is it can dissolve in water. Means alkalis are soluble in water. So they will dissolve in water. So water soluble bases are called as alkalis. So here we can write water soluble bases are called as alkalis. So water soluble bases are called as alkalis. So all bases cannot dissolve in water. All bases will not dissolve in water. Only few bases will dissolve in water. That bases we call as alkalis. The best example of alkalis, KOH and NaOH, CaOH twice. So these are water soluble. So these are called as alkalis. So alkalis are the substances which is alkalis are the bases which dissolves in water, right? So base which acts like which increases the concentration of hydroxide ion, right? So next, types of bases. Let us discuss types of bases. So what are the different types of bases that we have? Right? So they are based on different things. So types of bases. So what are the types of bases and based on what we have divided these bases? So what are the types of base? First type, based on water level. So based on water level, these bases are divided into concentrated, or we can also call as concentric and dilute. See, concentric or concentrated base is nothing but, see, as we discussed in terms of acids also, we have discussed this thing in terms of acids also. So what is concentrated? So here it will be having base as well as water. It will be having base as well as water. So the base in which base is more and water level is less. Base quantity is more and water quantity is less. Such kind of bases we call as concentrated bases. We can also call them as concentric bases. Concentric or concentrated, right? So here what is dilute base? Dilute base is nothing but the base in which base quantity is less and water quantity is more. Such kind of bases are called as dilute bases. Such kind of bases we call as dilute bases. So what is concentrated base? Concentrated base. The base in which base quantity is more and water quantity is less. Such bases are called as concentrated bases. Such bases are called as concentrated bases. Next, dilute base. So what is dilute base? Opposite to this. What is dilute base? The base in which base quantity is less and water quantity is more. Such bases are called as dilute bases. Such bases are called as dilute bases. So what are the examples that we can take for concentrated base or dilute bases? See, we can take all bases which are soluble in water. We can take all bases which are soluble in water. So if that is having water quantity more, then we can call them as dilute. If that is having base quantity more, we can call them as concentrated base. Clear? Right. So here we need to learn one more word, that is dilution. That is dilution. So what is dilution? Adding water to the base or acid. We call as dilution. We call as dilution. So adding water to acid or base. If we have taken, so I have taken one vessel. So I have taken one vessel into which I have taken base. I have taken base, right? I have taken a base, and in this, let us suppose these dots are water level. So in this less amount of water is there. In this, so this is base. Normally base will mix in water. This alkalis will mix in water. So this upper layer is called upper layer. Means these dots. Let us suppose if these dots are bases, these dots are water, and this down is base. So here base is more, water is less. Base is more, water is less. So this is concentrated base. This is concentric base. But now let us suppose if this base is 40 ml and this water is, let us only 10 ml. Right? Now to this, if I add 40 ml of water, if I add 40 ml of water, then what happened? water level increases. Water level increases. Water level increases. So, see here, more water level, less base. More water, less base. Then automatically we call them as dilute base. If water is more, dilute. So here, can you understand one thing? Can you notice one thing? See here, initially it is concentrated. We have taken concentrated base, but after adding water, it become into dilute base. So by this, can we confirm that on dilute? So we can dilute the bases on adding water. Right? We can convert concentrated base into dilute bases by adding water. Clear? Right. Thank you. Next. Next, bases based on acidity. Based on acidity. So what is acidity? Acidity is nothing but a capacity to release number of hydroxide ions. Capacity to release number of hydroxide ions on dissociation. On dissociation or complete dissociation, how many number of hydroxide ions that can release, that we call as acidity, right? So if a base, given base is releasing only one hydroxide ion, if the given base is releasing only one hydroxide ion, then we'll call it as monoacidic base. What is monoacidic base? The base which release only one hydroxide ion on complete ionization. The base which can release only one hydroxide ion on complete ionization. Such bases are called as monoacidic base. Next, examples, you can take LiOH, you can take KOH, you can take NaOH. So these are monoacidic bases, right? Next, if the base is releasing two hydroxide ions, see, one means mono, two means diacidic base. Then what is diacidic base? Diacidic base is nothing but the base which can release two hydroxide ions on complete ionization. Such bases are called as diacidic bases. The bases which can release two hydroxide ions on complete ionization we call as diacidic base. Next, if the base is releasing three hydroxide ions, then what we call? If the base is releasing three hydroxide ions, we call, three means triacidic base. Triacidic base. So the base which can release three hydroxide ions on complete ionization we call as triacidic base. So for diacidic base, you can take example of calcium hydroxide, right? Zinc hydroxide, right? So for triacidic base, you can take aluminum hydroxide, iron hydroxide, triacidic bases. So acidity, what is acidity? The capacity to release number of hydroxide ions on complete ionization is called as acidity. If the given base is releasing only one hydroxide ion, we call as monoacidic base. If the given base is releasing only two hydroxide ions on complete ionization, we call them as diacidic base. If the given base is releasing three hydroxide ions on complete ionization, we call as triacidic base. Clear? Next. The most important one, that is strength of base. Strength of base. Third one, strength. strength. This we can also call as ionization. Ionization. What is ionization? See, what is the definition of base? The substance which releases or which increases the hydroxyl concentration in water, or the substance which releases hydroxyl ions in water we call as base. So here, whenever you take a base, if you dissolve in water, then this will dissociate into Na plus and OH minus ion. So this will increase the concentration of OH minus ion. Right? So here initially NaOH is a neutral substance. This is neutral substance. So this neutral substance is dissociating into ions. So neutral substance becoming into ions we call as ionization. So here based on ionization, so these bases are divided into two types. These bases are divided into two types. What are the two types? First one, strong base. So what is a strong base? If let us suppose whatever the amount of bases that we have taken, if the total bases are dissociating into its ions, then we can call them as strong base. Let us suppose, so if I have taken NaOH, so if this NaOH is dissociating into Na plus and OH minus, one NaOH I have taken, one OH, one Na plus. So whatever the OHs it has, it is dissociating 100%. Let us suppose if I have AlOH thrice, and see in one step only one hydroxy ion can be released. So AlOH twice minus plus OH minus. So here it has dissociated one hydroxide and it is having two hydroxides. So here 100% dissociation not taken place. 100% dissociation not taken place. Only partial means little dissociation takes place. If any base is undergoing 100% ionization, if the same base, if let us suppose, if the same base, if it is dissociating and forming Al plus 3 and OH minus, so here 3 hydroxide. So here it is having 3 hydroxide and 3 hydroxides are released. So this kind of bases means the bases which can undergo complete ionization. The bases which can undergo complete ionization we call as strong base, and the bases which undergo incomplete ionization, incomplete. So the bases which can undergo incomplete. So incomplete we can also call as partial. Complete we can also call as 100%. Complete means 100%. Partial means that may be 10%, 20%, 30%, 50%, 60, 90%, whatever may be. Right? So complete not, that is not complete, that is incomplete. Clear? So the base which can undergo 100% dissociation or complete dissociation we call as strong base. So here this is for your understanding what is complete ionization, what is partial ionization, to make you understand that I have drawn this. Okay, to make you understand that I have taken same example, aluminum hydroxide only. Right? So what is strong base? The base that undergo complete or we can also call 100% ionization. So such bases are called as strong bases. Mostly potassium hydroxide and sodium hydroxide will call as strong bases. Mostly potassium hydroxide and this sodium hydroxide will call as strong bases. Right? Next, weak base. So what is weak base? The base that undergo complete, in place of complete we should write incomplete, or we can also call as partial. We can also call as partial ionization. If that is undergoing only partial ionization, we will call them as weak base. If that is 100% ionizing, we will call them as strong base. The remaining zinc hydroxide, right, copper hydroxide, so these are partial, not complete, right? So these we can take as partial ionization or weak bases, strong bases, right? So based on the bases are divided into three different types based on three things. First one is based on water level, second one based on strength, and third one based on acidity. Third one based on acidity, water level and ionization, right? So next, how can we prepare these bases? How can we prepare these bases? How can we prepare these bases? So preparation of bases. Preparation. So how can we prepare bases? Almost all metallic oxides, almost all metallic oxides acts like bases. Almost all metallic oxides acts like bases. So these metals, whenever these metals allowed to react with oxygen, they will form metallic oxides. Just now we have said, so almost all metallic oxides acts like bases, right? So few metals like aluminum oxide, so they'll act like acids as well as bases. We'll call them as amphoteric oxides. But mostly all metallic oxides acts like bases. So here metals reaction with oxygen. So sodium, if you burn sodium in presence of oxygen, then automatically it produces sodium oxide base. And if you make potassium to react with oxygen, then it will form potassium oxide. If you take magnesium ribbon and burn the magnesium ribbon in presence of oxygen, then this will convert into magnesium oxide, right? If you allow mercury to react with oxygen, so this will form mercuric oxide. So all these are metallic oxides. These metallic oxides acts like bases. So this is one method of preparation. So how can we prepare bases? On making metals to react with oxygen. So in that reaction you can say burning or you can say a reaction, right? So on reacting metals with oxygen, it will form their respective metallic oxides. So most of the metallic oxides acts like bases, right? So this is one method. Next, second one, on dissolving metallic oxides in water, we get metallic hydroxides. So these metallic oxides are nothing but bases. So let us take, so if I have taken same sodium oxide, so if I dissolve the sodium oxide in water, so I will get sodium hydroxide, and here heat energy is released. So sodium hydroxide, that is base. So adding water to this, adding water to base, that is exothermic reaction. So here heat energy is released. Clear? So sodium hydroxide and reaction with water, sodium oxide and reaction with water, that will convert into sodium hydroxide and releases some heat energy. So in any chemical reaction, if the heat energy is released, we will call that reaction as exothermic chemical reaction. So adding water to base, or adding water to metallic oxide, that is exothermic. So calcium oxide. So if you add water to this calcium oxide, this turns into calcium hydroxide. So calcium oxide, we will call this as slaculime. Slaculime is our slaculime. So to this, if you add water, then this will come into calcium hydroxide, which is a base. We use that for whitewashing of walls. When you coat this on the surface of the walls, it is having calcium hydroxide is having a special character. So that special character is nothing but, so this will immediately reacts with atmospheric carbon dioxide. This will reacts with atmospheric carbon dioxide and turns into calcium carbonate, and water is evaporated. And this calcium carbonate we can see on the surface of walls after evaporation of walls. So we will coat this calcium hydroxide on the surface of walls. When we coat the calcium hydroxide on the surface of walls, that calcium hydroxide is having special character that will absorb atmospheric carbon dioxide, and after absorbing atmospheric carbon dioxide, it will convert into calcium carbonate, and that calcium carbonate, from that calcium carbonate water will evaporate. After evaporating water from this, we can see the white wall, right? So this is about second method of preparation. On dissolving metallic oxides in water, we can get metallic hydroxide, and we can also get metals on dissolving in water. Sometimes these metals may form metallic oxides, or they may form metallic hydroxides. So just now we have discussed metallic oxides and metallic hydroxides. Both are basic in nature. So they both acts like bases. Clear? Right? So here this is one more method. So metals and dissolving in water, we can get metallic oxides or metallic hydroxide. So both metallic oxides and metallic hydroxide both acts like bases. Next, one more method, heating. On heating. So if you take calcium carbonate, on heating calcium carbonate, you will get calcium oxide and carbon dioxide will be released. So this is calcium oxide acts like a base. So this is a base on heating this, right? So similarly, NH4 OH on heating. So this will dissociate into NH3 and H2O. So this also again that will react with this and turns into NH4 plus and OH minus. So it increases the hydroxyl concentration, right? Dissociation and reassociation. So this we cannot take, but we can take this as best example: calcium carbonate or calcium hydrogen carbonate, bicarbonate on heating calcium hydrogen carbonate. So calcium oxide, water and carbon dioxide gas is released. So this is a base. Clear? So these are the methods of preparations of bases. Next, let us see the properties of bases. So just now we have discussed what is a base. Base is nothing but the substance which increases the hydroxyl ion concentration in water. But how can we know that a given substance is increasing hydroxyl ion concentration? How can we know that a given substance is increasing the hydroxyl concentration? So we don't know. So for that we should use indicators. So indicators they will changes their color on reaction with the bases, as well as some indicators they can changes their smell. So based on that we can decide. So in the next class, let us discuss regarding the properties of bases. Okay, thank you children.